Okay, so today we're going to be going over electronic structure. Um, that's another way, it's kind of a fancy way of saying how the electrons are organized around the nucleus. Okay, so to start off on page one, just remember that the central part of the atom is called the nucleus. You can go ahead and write that down on page one of your notes. The central part of the atom is called the nucleus. And then remember that these rings around the outside of the nucleus are called orbitals. And then the innermost ring is called the first orbital. And it can hold up to 2 electrons. So it can hold 0, 1, or 2 electrons. Okay? And then this second orbital, it's this second ring right here, can hold up to 8 electrons. And it's the same thing with the third orbital. That one can hold up to 8 electrons. Okay, so go ahead and write those notes down on your sheet, and then we'll move on to page 2. For page 2, when we're looking at the orbitals here, what I want you to know is that they increase in energy as you move further away from the nucleus. So what does that mean? That means that the electrons in the outermost orbitals are moving faster and thus have more energy. Right? So the electrons on the inside orbital are moving slower, the electrons on the outside orbital are moving faster. And electrons always fill in the lowest energy orbital first, or what we should say is they'll always fill up this inside orbital first and then start filling in the higher energy orbitals on the outside, right? And they'll just keep filling in until one orbital is completely full, and then they'll start filling up the next orbital. And so valence electrons, that's the name that we give to the electrons that are in the highest energy or the outermost orbital. So if you have an atom and the highest energy electrons are in this third orbital and there's 2 of them, then we would say that there's 2 valence electrons. If we had 5 electrons in this second orbital and that was the outermost orbital, then we would say that there are 5 valence electrons. We'll go through some more examples of this once we do some examples of drawing these atoms. Okay, so our first example is going to be the helium-3 atom, and we're going to practice how to draw this. So the first thing we have to do is figure out how many protons this atom has. Well, the key to that is looking at helium on the periodic table. Now, let me take a step back for a second here and remind you that this term, helium-3, this is referring to a specific isotope of helium. And so what I mean by isotope is it tells you specifically what the mass of that helium atom is. So this 3 is the mass. Okay, but we're going to start with helium, and we're going to take a look for that on the periodic table. And so helium is right here. This is helium, and it has an atomic number of 2, and so that tells us how many protons that atom has. So helium is going to have 2 protons, and that's again because of, on the periodic table, helium has atomic number 2. Okay, so 2 protons. Okay, and so then the next thing we're going to do is we're going to solve for the number of neutrons. Now, like I said, this 3 is the mass. Recall that the mass is just your number of protons plus your number of neutrons. So we know the mass, that's 3. We know the number of protons, that's 2. So then we just have to do a little bit of algebra to solve for the number of neutrons. So let's take what we know, the mass, 3, and the number of protons, 2, and we're going to plug it into this equation. So our mass is 3, our number of protons is 2, and we're solving for the number of neutrons. So we're going to subtract 2 from both sides of this equation because we're solving for the number of neutrons. So minus 2 and minus 2. 3 minus 2 is 1. 2 minus 2 is 0, so that cancels out. So 1 is our number of neutrons. So then we'll write that in here. Number of neutrons is 1. Okay? And then last up, because we're dealing with neutral atoms here in today's lesson, the number of protons and the number of electrons will be the same. Okay. The number of protons and the number of electrons are both going to be 2 for this problem. And for all of our problems, they're going to be the same. Sorry, that keeps jumping up. I'm not trying to do that. So number of protons and number of electrons need to be the same. Okay, and so then what we're going to do next is we're going to draw the atom now that we know how many protons, neutrons, and electrons it has. So the first thing we're going to do is we're going to draw on the protons. Right? 1, 2. Right? So we've got our 2 protons. Next we'll add our 1 neutron. Okay, and then we're going to put in the orbital. So the next thing that you should draw is the orbital. So that's just going to be a ring that goes around the protons and neutrons. And then the last thing that we're going to do is we're going to add those 2 electrons. Now remember that the first orbital can hold 2 electrons. So we're just going to put those 2 right there. Right? Those 2 electrons are in the outermost orbital. So we say that those 2 electrons are valence electrons. So this atom has 2 valence electrons. Right, 2 valence electrons. Okay, so let's go on to the next example. It's going to be very similar. We're going to follow the same steps. Okay, so in this example, we're dealing with the carbon-13 isotope. Right, the carbon-13 isotope. All right, so first things first, we got to find carbon on the periodic table. So let's take a look at our periodic table. Here's carbon right here. It is number 6. So that lets us know that it is atomic number 6, and therefore it has 6 protons. Okay, next we're going to solve for the number of neutrons. So again, we need to use the mass being 13 and the number of protons being 6. So mass is number of protons plus number of neutrons. Our mass is 13. Our number of protons is 6. So we'll fill that in. 13 equals 6 plus the number of neutrons. Then a little bit of algebra to solve for the number of neutrons. We're going to subtract by 6 on both sides. 13 minus 6 is 7. 6 minus 6 cancels out. 7 is our number of neutrons. And then just recall that our number of electrons is always going to be the same as the number of protons for these examples today. So it's going to be 6. Okay, and then we're going to start to draw the atom. So first things first, we're going to add in our 6 protons. So that'll be right here. 1, 2, 3, 4, 5, 6 protons. Then we're going to add in our 7 neutrons. 1, 2, 3, 4, 5, 6, 7 neutrons. Okay, then we will add our first orbital. Recall that the first orbital can hold 2 electrons. So we'll fill in those 2 electrons. 1, 2. Okay, now this orbital is full. So now we're going to have to start adding to the second orbital. Recall that this orbital can hold up to 8 electrons. We need to get up to 6 electrons total for this atom. We already have 2, so we're just going to add 4 electrons to our picture. And so now if we count the number of electrons, it's 1, 2, 3, 4, 5, 6. So 6 total electrons, that's what we were trying to get to. And so then the final question is how many of those are valence electrons? Well, remember, valence electrons are only in the outermost orbital, so we can ignore these 2 electrons in the innermost orbital. We're just going to include the 4 electrons in the outermost. And again, that's 4, so 1, 2, 3, 4. So then we're going to write in that there's 4 valence electrons. Okay, last example. This one is going to be the biggest one, though. We're going to do a sodium-23 atom. So again, first step is look at sodium on the periodic table. Okay, and so sodium is right here on the periodic table. It's atomic number 11. So that means that sodium has 11 protons. Okay, now we're going to do the same thing as we did before and plug into this equation. The mass of sodium is 23. I'm giving that to you. The number of protons is 11 right here. And we're going to solve for the number of neutrons. So to get the number of neutrons by itself, we're going to have to subtract 11 from both sides. 23 minus 11 is 12. This atom has 12 neutrons. Okay, number of electrons is the same as number of protons, 13. Okay, so then when we draw, we're going to draw in our 11 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, next we're going to add our neutrons. There should be 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we're going to add our first orbital. Remember, the first orbital can hold 2 electrons. So that's 1, 2. Okay, then we're going to add our second orbital. Second orbital can hold 8. So if we count how many electrons are in our picture right now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But remember that we're supposed to have 11 in our picture, so we're going to have to add one more orbital. Okay, so that's what we're going to do. Add our third orbital. And then we'll add one more electron. Right there. And now we're up to 11. We count the number of blue dots in our picture. You should count 11. So then the last question is valence electrons. How many electrons are in the outermost orbital? Well, in this problem, the outermost orbital is this third ring, this third orbital, and I only count 1 electron. So hopefully that gives you some sense of what you're supposed to be doing on this. Up next, you're going to go through 3 problems where you try and follow this process yourself, determine the number of protons, neutrons, and electrons for an atom, draw the atom, and then determine the number of valence electrons. If you have any questions, feel free to ask.